Welcome back to the Math Professors. If you enjoy content that can be found in any college math class, please consider liking, subscribing, and sharing. I'm Professor Van Hamlin. I'm going to cover graphing secant and cosecant functions. And we're going to use the fact that we know that they're reciprocal functions of both the cosine and sine respectively. So when I graph the cosine function and I also graph the sine function, we're going to use these graphs to be able to graph these ones right here. So what I know is that it has important points. Like the cosine has these nice important points, these key points of, it goes to 0, 1. So I know that the output of this thing is going to be equal to 1. It goes to, pi over 2, 0, pi, -1, and then so on. So what I'm going to be looking at is their outputs at particular angles. So, at 0, what would the output of the secant function be? Well, the secant function is going to be 1 over the cosine of x, and when I plug in 0, I get an output that's equal to 1. So what I know is what's going to happen here is these are the outputs of that cosine function. So when I plug 1 into here, this output of 1, the secant's going to be 1 over 1, which means the secant's actually going to be 1 as well. So it's going to be right here. It's going to be at that same output of 1. It's going to have an output of 1. Now, if I plug in pi, what happens? Well, remember the output of pi is going to be equal to this -1. So when I plug -1 in here, 1 over -1 is going to be equal to -1. So, at pi, this is going to spit out -1. So I'm going to get that value there. And then similar, when I plug in 2 pi, when I plug in 1, I'm going to get +1. So we can see that it shares all its, what's the max of this is going to be, a solution point of the secant function. Now, the more interesting parts is what happens at, like, say, pi over 2 and 3 pi over 2, or, wherever this thing crosses that x-axis. So, when I plug in pi over 2, the cosine of pi over 2 is going to give me, an output of 0. So what's 1 over 0 is kind of the question. And what we know is we've studied rational functions before this. So we know that as the function approaches 0, from any direction, what we can see is that we're going to get ourselves some asymptotes here. So I have vertical asymptotes at these particular spots. So at 0, it's going to have an asymptote here, which means, this also crosses the x-axis at 3 pi over 2, which also is going to give me an asymptote here. So then we have to ask ourselves, what direction is going to pull toward the asymptote? Well, let's investigate this direction here. What happens when I go to 0 or pi over 2 from the left-hand side? The outputs are getting close to 0, so, this thing is going to grow without bound. But I can see that, the numerator is positive, and up here we're talking about a positive number as well because I'm above that, horizontal axis. So what's going to happen is this is going to shoot off into positive infinity. But down here, as I approach this direction, the bottom is going to go to 0. This is going to go to 0. But the numerator is going to be positive, but I can see that below here the graph is below the x-axis, which means this blue output is going to be a negative number. So positive over a negative number is going to give me a negative number, which means it's going to shoot off into negative infinity. So as I come from pi, this is going to go off into negative infinity. Similar here, as I approach this, the output's negative, so positive over negative is going to go to negative infinity. And then similar as I approach, from this direction, I'm positive, so positive over positive is going to be positive, so it's going to go off into infinity. Now, we know that this graph, repeats itself over and over and over again. So there's going to be, more spots where this thing crosses, this is 0. So there's going to be, another asymptote here. There's going to be another asymptote here. There's going to be another asymptote here, and then so on. So, this function, just like the sine function, is going to repeat and repeat and repeat. So we can see that this does as well. Now, a lot of times we're only looking for a single cycle, so a single cycle being, the original piece that I drew. So a lot of times we're only looking for that, that single cycle. All right, let's go after the sine function. Now, the sine function has very, very similar properties. Let's go after the spots where it has, your max and min outputs. So your pi over 2, your 3 pi over 2. So what I know is when you plug in sine of pi over 2, this output here is going to be 1. So 1 over 1 is going to spit out, an output of 1. It's going to be up here. And then also at 3 pi over 2, we can see that this has an output of negative 1. So 1 over negative 1 is going to be equal to negative 1. So it's going to be here. Very similar, where it crosses the x-axis. We know that we're going to have asymptotes because I'm going to have 1 divided by 0. So we can see that it's going to have an asymptote everywhere where the function crosses the x-axis. And then very similar kind of shapes here that, this is going to go this way and this way and this way and this way. And, this function continues forever and ever and ever. So you're going to have more that, look like this and this and this and so on. So again, we usually only ask for a single cycle, and a single cycle being right here. So what I'm trying to really pull off here is the fact that if I know the graph of the sine function or the cosine function over here, if I know the graph of this thing, then I also know the graph of this thing. Doing like a single cycle, that I can graph it very quickly and easily. And same thing here. If I know, a cycle of the sine function, then I also know, a cycle of the cosecant function. So that's really kind of the goal. If I can graph this, I can easily graph this. Now, it shares the, these points at the max and mins, and it's got asymptotes where it crosses the x-axis. So let's graph, I don't know, a secant function. And we'll do it from a cosine function. So I'm going to give you a messy looking, say, secant function, and we're going to be able to graph this because we know how to graph cosines. All right, so I want to graph y equals 2 secant of 3x. And really what I'm just going to go ahead and start out with, because we're really familiar with this, is let's just start out with y is equal to 2 cosine of 3x. Because if I can find the key points to here, these key points will be related to the secant's key points. So what I know is, going through our unit circle, we look at our key points being our quadrantal angles. So, the cosine being the x coordinates of this thing. And then, of course, back to this. So this is going to be angle 0. We have angle pi over 2, angle pi, angle 3 pi over 2, and then back to 2 pi. So when I look at my 5 key points, we're going after angle 0, angle pi over 2, angle pi, angle 3 pi over 2, and then angle 2 pi. And then remember that the cosine are the x coordinates of these things, which I've done. 1, 1, 0, negative 1, 0, back to 1. So 1, 0, negative 1, 0, back to 1. Okay, so now what do these things do? What does the 2 and the 3 do, respectively? So let's go after the horizontal compression first, which means I have to divide all the x's by 3. Remember, what I'm doing is, technically, let's kind of just talk about this value right here. So really what I'm doing is I'm solving this particular equation for x. So when I solve for x, dividing both sides by 3 is going to make it pi over 6. So what's going to happen here is now this point is going to be, the angle is going to be pi over 6 comma 0, because what I've done is I've squished all the x's by 3. Similar here, dividing 0 by 3 is still going to be 0 comma 1, dividing all these angles by 3. 3 divided by 3 is going to cancel that 3, so this is just going to be pi over 2 comma 0, and this will be 2 pi over 3 comma 1. So what that has done is taken care of that horizontal compression. Now what I have to do is I have to multiply now I have to do is I'm going to have to multiply all the y's by 2, because what this is nothing more than a vertical stretch of 2. So really what I'm really doing is just saying 2y, y being, these coordinates here is how I'm pulling this off. So this is your x compression, which means you're using algebra to do that, and then your vertical stretch, you're using evaluation to do this. So just multiplying all the y's by 2. So, the x's stay the same, and then I'm going to have to just double all the y's. Okay, so 2 times 1 is 2, 2 times 0 is still 0, 2 times negative 1 is negative 2, 2 times 0 is still 0, 2 times 1 is 2. Okay, so what I know is if I want to graph this y equals 2 cosine of 3x, I have all the key points here and all the angles. So, angle 0, angle pi over 6, angle pi over 3, pi over 2. Finally, 2 pi over 3. Remember, it's divided all the x's by 3, and then I also stretched all the y's by 2. So instead of going from negative 1 to positive 1, this goes from negative 2 to 2, and it's a cosine function, so it should start right there. Okay, boom, 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 and boom. Okay, so this is our cosine function. Now again, I have these nice key points of the cosine function. So when I want to graph y is equal to 2 secant of 3x, well, these key points are very much related to the key points here. So I know I'm going to go to the same angles. I should say 0 to pi over 3, pi over 2, 2 pi over 3. And then almost the same kind of outputs you would kind of say, except only at the key points, not at the max and min. So, it's going to share the same point up here. It's going to share the same point down here. It's going to share the same point up here. And then what we know is that your x-intercepts are going to become your asymptotes here and here. And then we have a bunch of u's that go up and then also down. So, this is going to be this shape. It's got that same exact shape that we were talking about before. So again, this reinforces the fact if you can draw a cosine, you can draw a secant. One more. Let's do it for a cosecant function, and let's maybe do a horizontal shift in here as well. All right, so if I want to graph this, what I'm going to do is, again, start out with the corresponding reciprocal function. So y is equal to minus 4 sine of 2x minus pi, because if I can find these key points, then they're related to these key points. All right, so let's go after the key points first. Now remember that the sine function are going to be the outputs now. Well, the y coordinates. So this is going to be coordinate 0, coordinate 1, coordinate 0, coordinate negative 1, and then our angles still. So our key points are 0, pi over 2, pi, 3 pi over 2, 2 pi, and then since that's a sine function, we worry about the y coordinates. So 0 comes 0, 0 comes 1, 0, negative 1, back to 0 again. Okay, and then we worry about what these things do. So first what I'm going to have to do is we have this 2x minus pi, which is going to manipulate our x coordinates. So, first, let's go after that pi over 2 again, because it's kind of an interesting coordinate. So the first thing you're going to have to do is add pi to that. So 2x adding pi, well, this is 2 pi over 2 plus 1 pi over 2 is going to be 3 pi over 2. So, when I first add pi, this is now going to become 3 pi over 2. And then what you're going to have to do is you're going to have to divide both sides by 2, because I still have to squish it. So this is going to become 3 pi over 4. So then when I divide by 2, this is going to become 3 pi over 4 comma 1. So really I'm just manipulating the x coordinates. So let's go after that. So let's do that with all of these. So remember that the y coordinates are unchanged. I'm just going after the x's right now. Okay, so first things first, add pi. So adding pi here, 2 pi over 2 plus 3 pi over 2 is 5 pi over 2, and then adding pi is going to be 3 pi. Then I have to divide everything by 2, so this will become pi over 2, 3 pi over 4, this will become pi, divide that by 2, 5 pi over 4, divide this by 2 is going to be 3 pi over 2. Okay. Now the last thing I have to do is I have to multiply all the x's, so all the y's by negative 4. So multiply y's by negative 4, which means it's going to stretch it and flip it over the horizontal axis. So in this case, the x's are unchanged, but multiplying everything by -4 is going to do this. Okay, now let's look at this thing's picture. How are we going to graph this? Well, looking at the key points, we'll start out with y is equal to, well, that's what we're doing right here. And then we'll do the secant x. All right, so I know that I've been shifted to pi over 2, 3 pi over 4, pi, 5 pi over 4, 3 pi over 2. So those are my angles. Pi over 2, 3 pi over 4, pi, 5 pi over 4, and then 3 pi over 2. And we've had a stretch of 4, then, a reflection. So here we go, 4, -4. Now it starts at 0 because it's a sine function, so here, and then it's going to go down to -4, and then it's back up to 0, then back up to 4, and then down back to 0. So that's why our sine function looks like it's upside down, because they usually start this way, and the reason why it's got that negative here that flips it over that horizontal axis. And that's going to be our sine function through one cycle. So now when I do my cosecant function, what is nice is I have the same angles. 1, 2, 3, and 4, 5. Pi over 2, 3 pi over 4, pi, 5 pi over 4, and then finally 3 pi over 2. And then we still have that same, stretch going on here. Now remember that the outputs for, your mins and maxes will be the same. This is still going to be down here. This is still going to be up here. But their differences are all your x-intercepts end up being vertical asymptotes. So I can see I'm going to have an asymptote here, another one here, another one here, and then we have that same kind of u up and u down kind of thing going on. So this will shape down. This will shape up. And again, these things, this is just a single cycle. It's going to keep repeating itself over and over again, this way and also this way. So back to the same statement. If you like the content, please subscribe.